Information we really need off that original sheet is just right here. Like I said, this is just for the shop. Unfortunately, everything in the office does have to be like what we just talked about, but the shop at least is gonna be a little bit easier, so. So we'll kind of start out filling this out very similar. So we'll say our room, that's our shop. If we pull up the shop drawing, I'm actually a little bit of a hypocrite. I did a long time ago what I said for what I tell y'all not to do, and I accidentally deleted the text in there. But if I remember correctly, the shop is a 217 by 176 area, right? Somebody
Yeah.
verify that?
Yeah.
Real quick. Yes, thank you. So, our length, 217, width, we'll say 176. And we'll still need the area, so we'll do 217 times 176. And that brings us to an area of 38,192 foot squared. And then our type of fixture also changes in the shop. So we're gonna be using a little bit different fixture. So if we go back to our bulletin book, of course I'm already on this page here from our office lights, but if we keep scrolling just a little bit, you'll eventually get to page 30. And that's where you'll see on there where it says round high bay at the top. Again, this is on page 30 in the bulletin book. And this is actually going to be the light fixture that we're using in our shop. So, if we kind of look at the pictures, because this one's a little bit better to look at, but if we kind of look, especially on that second page there, we can see that this is a pendant style light. So whenever I go back to my Excel sheet, our mounting type, I'll indicate that as a pendant style rather than a surface style this time. For our manufacturer, that's actually going to be ETI. So we can put that on there. The fixture description, that is the round high bay. Oops. And then they don't necessarily call theirs a catalog number, they call theirs a model number, and that is model 502-28561. If we look here, our lamp type, it's still an LED, so we'll include that. So lamp type is still an LED. And our lumens, so if we scroll down, specifications, it says typical lumens is 38,000. So it puts out quite a bit more light compared to our office fixtures. So, since we kind of gutted this Excel page, we have all this room down here at the bottom. This is where we're gonna kind of show our work utilizing this calculation here. So we're gonna end up using this calculation. That is our number of shop lights, however many we need in the shop, is equal to our area times 10.764 divided by our lumens per fixture. So this one's also kind of a freebie for y'all. But our area, we said, was 38,192 feet squared times that 10.764. All divided by our lumens per fixture. Well, each fixture is going to output 38,000 lumens. So when you punch that into your calculator, don't forget the parentheses on your numerator there. But what do you calculate when you put that in your calculator there?
10.81.
So that comes out to
10.82.
82? Okay. So 10.82. So how many light fixtures do y'all think we should put in the shop?
12.
I would agree with that. I would put 12 in there. So like I said, that one's kind of a freebie for y'all, so that's a group activity. So everybody has the same shop, same dimensions, everybody's using the same light.
And then we just do the same process as we did for the one room, just with obviously bigger distances and stuff.
Right, exactly. So this right here, don't just put on there shop lights equal 12, right? So again, list out this formula just like what I did here. So say, hey, this is my formula. Here's my values that I'm putting in. This is what I calculated, and this is how many lights I'm going to use. So this math that we just did right here, since we got all this extra room now on our page, you're going to show that work on here. So shop lights start out very similar as our office lights, right? We have to do the calculation to determine, well, how many lights do we need in the shop, right? Except there's one extra step with the shop lights. So in your shop, we don't have kind of a, very similar like the receptacles, we don't have a main panel located somewhere in the shop that's just dedicated for receptacles and another panel just dedicated for lights, right? So, kind of like the receptacles, it's just now only one MCC is going to carry the load of our shop lights. So we have to determine, well, what MCC is going to carry that load? So this is where your one line drawing is going to come in to today. So, looking at your MCCs, we're going to have to install a panel in any one of these 6 MCCs in sections 1 through 5. So, with the panel that we're going to install, we come over here back to our bulletin book. Kind of want to follow along a little bit. This is on, page 7 of your bulletin book. It's this bulletin 2193 LE, bolt-on lighting panel. So there's 2 options. You can get one that's main lug only or one with a main circuit breaker. So the main lug only is actually like what y'all used in your code class, right? There was not a big breaker up at the top, very center of that panel. It just has lugs there, which is good for, you know, things like sub panels and things like that. But we don't necessarily want that. We want the one that has a main circuit breaker. Just like if you open up the panel in your house or apartment, how there's that big breaker up at the top center, that's what we want. So that's this kind of bottom half down here with a main circuit breaker. If we look here, we have 2 options. One's a single phase panel, which that doesn't really make a whole lot of sense for us, right? Especially if we have 3-phase available, we would like to use 3-phase, right? It's all that balancing act. So we don't really want the single phase panel, but if we look there is a 3-phase panel, but it's only listed as 120/208 volts. Well, if this is going to be plugging directly into our MCC bus, what voltage do we have present on our MCCs?
480.
480. So if you notice there, we kind of have a little note, handwritten note, kind of tied off to this panel here. And it says, same as 480/277. So we're basically saying that, and again, this is kind of our project here in school, so we can kind of make up some of this stuff. But we're going to say that there's an identical panel, just the one that's listed there, but it's also listed for 480/277 volts. So they have the same specs, same requirements, same everything. It's just this one's also going to be listed for 480/277. So if we look here, that 3-phase panel, it has 100 amp main lug rating, so meaning that the main bus bar system, that main breaker up at the top, should be rated at 100 amps, which is more than enough for what we need. It says that we can hold up to a maximum of 15, really that's 16 circuit breakers in there, or circuits, and that more importantly takes up 2.0 space factor. So that's kind of what we're focused on today, is that space factor requirement. So when we're looking at your one line, again, this panel can go inside of any one of your MCCs. It does not matter. I don't really care where it goes, just wherever you have the space. But in any MCC, in sections 1 through 5, you do have to add that shop lighting panel. So there is kind of that extra step. So this would be like step 1, step 2, is adding, I'm going to say shop lighting panel, but we abbreviate that to SLP.
Going in that 6 section again?
That's actually going to be some equipment for our receptacles. We'll actually talk about that here in a couple weeks. But we have to add the shop lighting panel to any MCC in either sections 1 through 5 on our one line drawing. So like I said, wherever you have the space for 2 consecutive space factors, that's where we need to input that. So for example, in my MCC over here, of course, y'all should be filled out. Mine's blank. But let's just say I had spares right here. So I would delete the spare text. We would visually represent that 2.0 space factor. And as far as adding the panel, all we're going to do is add some text. And we're just going to call that our SLP, our shop lighting panel. We'll want to list what voltage we have present in that panel, which that's going to be 480/277 volt. We'll also indicate that it is a 3-phase panel. And then we also want to put the number of circuits on there. So, talking about that just for a second. If we come back over here to our bulletin book, this is one of the few times where we're not going to have that magical 1600 watts per circuit just for our shop lights. Probably one of the few times. But if we look here, a couple of things to denote is it says input voltage for our shop lights is 120/277. Well, what does that mean?
That's a step down, right?
Not necessarily. But if a piece of equipment has two different voltages listed on it, what does that typically mean? kind of think back to our air conditioning when we looked at that.
Can you step back again?
Huh?
What was the question again?
So on our shop lights, it says for our input voltage, it says 120-277. What does that exactly mean?
It's like a delta.
Can you Delta Y?
Not quite delta Y, because both of those are, well, for the most part, those are gonna be Y voltages, right? The 120 could be a delta, but it's two different voltages, right? So you can utilize this light depending on if you have 120 or 277 available to you, right? So that's what that voltage is meaning, is that it can operate on 120 or it can run on 277. Well, since we're putting this panel into our MCC and it has 480, 277 available, it's gonna run on 277 volts. So that's kind of good for us to know. But then here, it's also telling us our wattage is 270 watts. Well, if we put all 12 of these lights on one circuit, that would be 12 times 270. So if I do that calculation real quick, yep, that's what I got. I got 3.24 kilowatts. But you might say, oh, well, that's a lot more than that 1600 watts that we usually shoot for. You're right. However, like what we just talked about, we're not running at 120 volts anymore. So if we took this and divided it by 277 volts to figure out what our amperage would be, that comes out to, we'll just say that's 11.7 amps. Not even 12 amps. Most likely this is gonna have at least a 20 amp breaker on it, protecting that circuit, which is more than enough, right? However, that would be all 12 lights on one circuit. So a couple of things with that. One, this deal that y'all talked about a whole bunch in your advanced AC class, load balancing, y'all remember talking about that? That's not very efficient, right? Especially if we have a 3-phase panel. And then, if we ever had to replace one of these fixtures, guess what? The entire shop goes dark when we lock and tag this out. That one circuit feeding all of our lights. So, it poses a couple of issues there for us. So what we're going to do is, thankfully this all works out all nice and even, but since we have 3 phases, we're gonna make 3 circuits. So if we did that, how many circuits would we actually have? Well, that's how many lights would be on each circuit,
Oh,
right?
read it.
Yeah, I know what y'all are saying. So we would actually do 3 circuits, and 3 circuits, 1 for each phase, A, B, and C, of 4 lights. So that is what I strongly recommend that you do. You can technically, however, put them all 12 on one circuit if you wish, but I'm just letting you know that also will be a factor here in a few weeks when we get to main feeder calculations. Yeah.
And those will all be pointing at the MCC that we chose to put the lighting panel in.
Correct, yes. So whatever MCC you decided to put that one lighting panel in, all those circuits are gonna point back to it. Correct.
I'm guessing we're gonna also have to put that lighting panel in an MCC where we still have extra circuits available.
Not necessarily, because the panel that we're installing, we just looked at said it can hold 15, really 16 circuits in it.
Yeah.
If we're only gonna put 3 in there, we only need that one
Well,
lighting panel.
I'm talking about just towards that MCC, or is this completely different from that? Because the MCC, we have that max amount of circuits per.
Oh, yeah, that was for our receptacles though.
Okay.
Yeah, this
oh,
is-
this complete. Oh, okay.
Yeah,
I
yeah,
didn't know if
that's
it would
like
be-
the power circuits, the receptacles, and the lighting
Okay.
circuits, that's like apples, oranges, and tomatoes, right? They're like all different things.
Okay.
So, yeah, the 16 thing, that was true for the receptacles, but not for the power circuits and not for the lights. So this is its own
Okay.
thing going on here, yep. I see what you're saying. Yeah. But like I said, you technically can put all 12 lights on one circuit if you wanted to. I don't recommend it. I strongly recommend you make 3 circuits of 4 lights. Because like I said, that will be a factor on whenever we get to our main feeder calculations here in several weeks. But kind of going back to how we got on that discussion was on our panel that we're drawing in on the one line, we want to list out how many circuits are on there. So if you're like me and you're doing the 3 circuits of 4 lights, we can already go ahead and put on there, hey, this is going to be 3 circuits. Whoops. So your finished product for that shop lighting panel should look something very similar to this. So we want to label what that panel is, what voltage is present in that panel. We'll put the number of phases and how many circuits are on there.
You'll be able to put that on one of the MCCs, right? Not all 16.
Correct. Only one MCC is going to house this panel. Yep.
Do we have 2 of those breakers? I noted that, you said 2 consecutive.
Oh, 2 consecutive space factor.
Okay.
Space factor, yeah. So this panel is gonna take up 2 space factors. So just like the buckets, whenever we put in our machines and everything, we're gonna visually represent that 2.0 space factor with this panel. Yeah. So everybody's good with installing the shop lighting panel? Like I said, this is only gonna go in only one MCC. You're not gonna have multiple MCCs with the shop lighting panel. We only need one shop lighting panel because we're only gonna have 3 circuits in it. So that panel can handle up to 16. We're only gonna put 3 in there. We're good. So everybody's good with the panel? Okay. So like I said, there is that extra added step in there. Once you kind of get that figured out, then you can go back to the shop and draw in the lights for the shop. Since this is a different light, and even just looking at the picture, this is now a circle. And if we kind of scroll down and look at the dimensions, it's basically an 18-inch diameter circle. So whenever you draw that in, it's gonna be this exact same process of what we did here for the lobby. It's just on a much larger scale, right? And if you're concerned about like the circle, 'cause like I said, this shop light, it's got an 18-inch diameter, or all but 18-inch. So whenever you do this process here, if you need to, you can just take a line from these 2 points here and kind of draw the box, or a corner of the box. You don't have to draw a box around the light, but you can kind of draw this corner point right here. And then that will be kind of where your leader line goes, just like how this corner point was over here, right? So if you need to do that, that's fine. Unlike the office though, there is already a block made for the shop light itself. So there is a symbol already made, and yes, it is to scale and everything. Very similar to the office drawing. There's those 3 purpley pink kind of layers there. It's the exact same process. Draw in the lights, space them out, tie them together, put the tags on there, point the arrows back to the MCC.
If we're gonna have 3 lines, does it matter if it's vertical or horizontal?
Nope.
No, we don't have to worry about the.
Yeah, layout, however you want to lay them out, it's very similar, like however many columns or rows of lights you want to do. Your 3 circuits, I mean, you're going to tie whatever 4 lights together you want to make a, I mean, there's not a right or wrong answer there. Yeah, or like I said, if you want to tie all 12 together, that's fine too. But just kind of, like I said, keep in mind that'll throw you off on your main feeder calculations a bit different. So. Do you have a question? Adrian? You have a question?
I was writing, when you pull that little line up, what did you insert?
Yeah, that's just the block library. Yeah, there is a block for the shop light in the shop, unlike the office. Alright, so, is everybody good with the drawing for the shop lights? So very similar, once you have your shop lights drawn in, you then have to calculate the wire size needed for the shop lights. So if you come back to the Excel book, and go back up to the front, there is a page on here for your shop lighting wire size. And it looks identical, or very similar, to the receptacles and the other lights. The only thing that changes is your notes over here off to the side. That's the only thing different. We still have 3% for a branch circuit. It's just now at 277 volts, which gives us a max voltage drop of 8.31 now. And this, like I said, is one of the only times where we're not gonna have that magical 1600 watts. So each receptacle or each light is 270 watts, just like what we saw on the manufacturer page. If we put 4 lights per circuit now instead of all 12, that only gives us 1080 watts. Divide that by 277 volts, that only comes out to 3.9 amps. So very low circuit loading, which is okay, but we can run that number 12 a lot further now because we have that higher voltage pushing everything along and a lesser load in terms of amps. But you'll go in there and then put your circuits, get the distance, back to whatever MCC that it's fed out of, just like what we have been doing. Okay.
The rise and fall?
Oh, yes, thank you for asking that, almost forgot. The rise and fall on the shop lights, that will be 34 foot. 34 foot. Thank you for reminding me about that. So rise and fall for the shop lights will be 34 foot. Everybody's good with the shop lights? Like I said, they're exact same process, it's just we got this one extra added step in here of adding our shop lighting panel and an MCC. Alright, so as far as looking at the schedule, like I said, I know